Hello and welcome to this Chemistry Essentials video on acid-base neutralization reactions. A neutralization reaction is a chemical reaction between an acid and a base in which a hydrogen ion or a proton is transferred from the acid to the base, allowing them to neutralize each other. This produces an ionic salt and water. An important note is that these reactions take place in the presence of water. Now for a review of acid-base chemistry. An acidic solution has excess hydrogen or hydronium ions, and a basic solution has excess hydroxide ions. The Bronsted-Lowry definitions state that acids donate protons and bases accept protons in aqueous solution. A strong acid or base reacts completely. For an acid, this means that all acid molecules will dissociate in solution. A weak acid or base only reacts partially and will establish an equilibrium. For an acid, this means only a fraction of acid molecules will dissociate in solution. Now onto conjugate acid-base pairs. This is a pair of an acid and a base that are related to each other by the transfer of a hydrogen ion or a proton. For example, hydrofluoric acid will donate a proton and become fluoride ion, the conjugate base. Another example is ammonia, a base, accepting a proton and becoming ammonium ion, the conjugate acid. For example, in a hydrofluoric acid solution, hydrofluoric acid molecules react with water molecules to produce fluoride ion and hydronium ion. When hydrofluoric acid donates its proton, it becomes the fluoride ion, which is the conjugate base, and when water accepts this proton, it becomes hydronium ion, which is the conjugate acid. So, hydrofluoric acid and fluoride ion would be a conjugate pair, and water and hydronium ion would be another conjugate pair. Something cool about water is that it reacts with itself. So even in pure water, water molecules are constantly reacting with each other, producing hydronium ion and hydroxide ion, and then these ions will react with each other again to produce water molecules. This process is called the autoionization of water. This makes water amphoteric, meaning it can act as an acid or a base. One water molecule will donate its proton, and another water molecule will accept it, which allows water to autoionize. The first type of neutralization reaction is strong acid plus strong base. This produces water in a pH-neutral salt, creating a neutral solution. An example is the reaction between hydrochloric acid and sodium hydroxide, producing sodium chloride and water. To write the complete ionic equation, separate hydrochloric acid, sodium hydroxide, and sodium chloride into their ions, since they dissociate completely in solution. Cross out spectator ions on both sides, and the net ionic equation becomes the formation of water. This solution is neutral because water and the spectator ions do not affect the pH. Next is weak acid plus strong base. This produces water in a conjugate base salt, which will create a slightly basic solution. An example is the reaction between hydrofluoric acid and sodium hydroxide, producing sodium fluoride and water. To write the complete ionic equation, separate sodium hydroxide and sodium fluoride, but not hydrofluoric acid, since it only partially dissociates in solution. Cross out spectator ions, and the net ionic equation becomes hydrofluoric acid reacting with hydroxide ions, producing fluoride ion and water. The leftover fluoride ion, which is the conjugate base, will react with water and produce hydroxide ions, making the solution basic. Similarly, when a strong acid and weak base react, the pH of the solution will be slightly acidic due to the leftover conjugate acid reacting with water. Something to be careful of is that it is not possible to have a neutralization reaction between a weak acid and weak base, since at least one solution needs to be strong in order to drive the reaction forward. An application of neutralization reactions is acid-base titrations. This procedure is used to determine the concentration of an acid or base by neutralizing it with a solution of base or acid whose concentration is precisely known. In this setup, the analyte, whose concentration is not known, is in a beaker placed under a burette which contains the titrant, whose concentration is known. A quick phrase to remember for neutralization reactions is acid plus base makes salt plus water. Thanks for watching this video, and I hope it was helpful.